Currently, discovering world-class mineral deposits is a significant challenge, raising concern about the impact that declined mineral production will have on the development of future societies. The application of more efficient mining exploration techniques could bring us closer to new discoveries. In the 90s, Weaver and colleagues defined the mineral system as a set of geological factors that enable the formation of a world-class mineral deposit, while McGuire and Wronski in 2014 identified 4 of these geological factors as critical: architecture, geodynamics, fertility, and preservation. Welcome everyone to today's episode from the SCG student chapter of the Universidad Nacional Mayor de San Marcos. On this occasion, we have the participation of Fernando Rivera, senior geologist at Antofagasta Mineral, with over 20 years of experience exploring South America. He will explain the importance of understanding and applying the mineral system approach.
Hi, my name is Yampier de la Cruz, and I'm here with Diego Celi. We are both geology students at Universidad Nacional Mayor de San Marcos, here in Lima, Peru, and the host of today's episode titled 4 Factors, 1 Discovery, Exploring the Mineral System Approach.
Hi, my name is Diego, and I hope you enjoyed this episode. Today, we have the opportunity to talk with Fernando Rivera, senior geologist at Antofagasta Minerals, who will explain in more details the mineral system approach and importance in mineral exploration. Welcome, Fernando.
Good morning, and thank you for inviting me to this SCG session. To be honest, I found it interesting to discuss this topic with the students, and I hope it will be very helpful.
Thank you, Fernando, for accepting the invitation. As you mentioned, the topic is really interesting. It's a new concept that we've only heard about in some international talks. I would like to start this conversation by asking you, what is the mineral system approach?
This concept is a methodology focused on recognizing a set of geological factors necessary to generate an economically valuable mineral deposit. These geological factors are defined by 4 critical variables: geodynamics, architecture, fertility, and preservation.
That sounds great, but how does this concept help current exploration trends?
Its application is developed at different scales and focused on searching for mineral deposits in regions where these 4 variables are concentrated. In this way, reducing the search space, improving the prediction of a new discovery.
You know, it sounds like ingredients for forming a great deposit, but where should we start exploring according to this approach?
First, areas that represent the best combination of critical factors must be defined on a bit scale. Then, a ranking process is necessary to prioritize the type work in each selected area. It is very likely that one of these areas contains a drill target and a future discovery.
It's interesting how analyzing different factors can help define a deposit. Also, we often talk in class about the planet's geodynamic and the convergent and divergent margin of tectonic plates. How can these processes contribute to the formation of mineral system?
Yes, as you said, geodynamics is related to the tectonic evolution that affects the internal structure of our planet during specific periods of geological time. This tectonic event can generate a mineral deposit due to the dynamic change, such as variation in solution of tectonic stresses. Generally, orogenic processes are the most favorable events since they involve continuous magma generation over a characteristic geological time frame.
So, the Middle Eocene could be a specific period that developed favorable geodynamics, right? We know that during this time, Las Bambas porphyry scar deposit in southern Peru was formed.
That's right. Las Bambas is associated with the Inca phase of the Andean orogenic, characterized by a compressive event that generates magma. The magma associated with the mineralization of Las Bambas deposit formed between 38 to 35 million years.
The second factor that you mentioned was architecture, right? What do you mean by that, and why is it considered a critical component?
It is considered critical because this variable is associated with world-class deposits. Architecture is a structural pattern of very deep faults, which serves as permeability pathway for ascending hydrothermal fluids. For example, in southern Peru, we also find porphyry deposits like Cerro Verde, Cuajone, Toquepala, and Quellaveco, which are controlled by the northwest-southeast trending in Cappuccio fault system.
But if these faults are so deep, they may not be easy to detect in the field.
Some faults are challenging to determine in the surface. To define them, we can use tools such as geophysics, regional geochemical analysis, or remote sensing.
The development of new technology is very useful in various aspects. Maybe they can help us to identify the third factor, or how can we determine if an area is fertile.
Fertility is the capacity of a region to have a developed economic mineralization. This critical variable is associated with the physicochemical characteristics of the host rock and the geochemistry of magmas and hydrothermal fluids.
This happened in the Antamina porphyry skarn deposit, right? Because the limestone and intrusion were fertile and formed a world-class deposit.
Your statement is correct. Fertility in Antamina is represented by its high mineralization content. This deposit formed in a fertile sequence of humasha limestone in contact with a fertile Miocene intrusion. Currently, we can study zircons from intrusions to determine their geochemistry and assess if they show a suitable oxidation and hydration signal.
With these three factors, is it enough to form mineral deposit?
A deposit can form, but its preservation must be evaluated. That is, it must be assumed near the surface to be economically viable, but not so assumed that it has eroded and is no longer preserved.
Yeah, you're right. I totally forgot the last variable. Why do we need to know if it's preserved?
Because we need to determine if the highest mineralization content is still available. This variable can be evaluated by considering hydrothermal alteration, assemblages, and regional erosion rates. For example, based on Celito's diagram, the Yanacocha district contains a set of well-preserved high-sulfidation epithermal deposits associated with a deeper porphyry deposit.
This concept makes exploration seem easier and appear to have great potential.
I was about to say the same thing, Diego. These factors provide another perspective on exploration, even in an organized way.
Rather than easy or simple, I would call it practical and effective since it also allows for more logical decision-making in exploration, increasing the chance of finding a promising target and representing a better investment for mining companies.
You're right, Fernando. Geology isn't easy, and even applying this practical concept requires a trained and experienced person.
With these final thoughts, we can move toward to the end of this section of our podcast. This has truly been an insightful and informative conversation. Thank you so much, Fernando, for this introduction.
I totally agree. Now, I want to continue analyzing Peru's major deposit and identifying their critical factors. Thank you for joining us.
It's always a pleasure to talk about geology, especially with curious and motivated students. Keep going with your projects, guys. Peru has immense potential, and this concept will continue to drive new discoveries. Greetings to the listeners, and thanks again for having me.
We thank the Society of Economic Geologists for allowing student chapters to participate in activities that connect industry professionals with passionate students. We also appreciate the support of Universidad Nacional Mayor de San Marcos SEG student chapter, Yesenia Fernandez and Harold Aguilar as production team. The license was provided by Andres Carreño. Hope you enjoyed this episode and see you soon. Bye bye.